a pyramid and a prism is. So when you have a pyramid, we have the following things happening, okay? The difference between a pyramid and a prism is a prism has two bases. It has the bottom, it's the same as its own top. In a pyramid, you have how many bases now? You only have one base because now your top is meeting at a point. Connor?
Well, what if it's like a three-sided base?
A three-sided pyramid?
Like three bases?
Three bases, no. What do you mean, three bases?
Like instead of having like the square on the bottom as a base, like one of those.
It could still be a triangular pyramid. That can exist. Okay. So if you have a pyramid, that means it has a point at the top, which we call the vertex. We still have lateral edges, but now notice your lateral edges are slanted. The triangles around the side are lateral faces. You got your base, and you got your base edge. We would call this a regular pyramid because it has a perpendicular height straight up to the top. Okay, so your height is that perpendicular distance. But now it's going to change. Instead of just a normal height, we're going to have something that's called the slant height. And the reason why we need to care about the slant height is because if we think about how we find surface area, remember that's just taking all the areas of all the faces and adding them together. So in this pyramid, your bottom shape is a rectangle. We could easily find that area by doing length times width. But now if you look at your lateral faces, which all are triangles, and they will always, always, always be triangles, okay, for a pyramid, the height of your triangle is not the same thing as the height of the pyramid. Your height of the triangle is on the actual triangle itself, so we call that the slant height. So can you see the difference between a normal height and a slant height? So your slant height is the height of the face of the triangle. Your height is the height of the prism. Okay, so here's an example. We have a regular square pyramid that has a height of 15 centimeters and a base edge length of 16 centimeters. Find the area of each lateral face of the pyramid. All right, so we're told my base edge is 16, and since it's a square pyramid, I know that all of the other bases edges have to be 16 all the way around, right? I'm told that the height of my actual pyramid is 15, but I need to find the area of one of the lateral faces, which is a triangle. And in order to find the area of, I don't know why this is written here like that, to find the area of that triangle, we have to do 1/2 base times height. Not 1/2 base. Okay? We use a cursive L to represent the slant height because that is the height of my actual triangle. So now what do we notice? Does everybody see inside of this pyramid I have a right triangle? Yeah? So one of my legs is 15. What would be this leg right here? 1/2 of 16, so 8. And now notice that my slant height is the hypotenuse of that right triangle. Does everybody see it? Might be able to see a little better on yours, I don't know. So if I use the Pythagorean theorem, I'm going to get rid of that 16 because that's kind of looking like it's on the hypotenuse. If I use the Pythagorean theorem of 15 squared plus 8 squared, and then equal it to x squared, that's going to get me my slant height. So let's go ahead and do that. So 15 squared plus 8 squared is equal to x squared. 15 squared is 225. 8 squared is 64. Equal that to x squared. So 4 plus 5 is 9. 6 plus 2 is 8. Bring down the 2. Is that a perfect square? 289? It is. It's 17. So square rooting gets me 17 is equal to x. That means my slant height in this diagram is 17. So how would I find the area of just one of those triangles? 1/2. What's the base of the triangle? 16. The height we just found is 17. So let's go ahead and do that. So 1/2, 16 times 17. So half of 16 is 8. 8 times 17 is 136 centimeters squared. So find the area of each lateral face of the pyramid. Well, each lateral face would be all the same at 136 centimeters squared. Okay. And the reason why they are all the same is because the base is a square. So that means all of your dimensions would be the same. If it was a rectangle, then it would be different. Your front and your back triangle would be the same, then your side ones would probably be a little bit smaller. Okay? So, do we have our idea and concept around slant height? Because you're going to need to do slant height when you're finding surface area. So our surface area formula for a regular pyramid is as follows. So again, capital S stands for surface area. Now, unlike a prism, we only have one base, so that's why it's just 1b and not 2b, like our prism formula. And what did we say the shape of the lateral faces will always be of a pyramid? They will always be triangles. So what's our formula to find triangles? 1/2 base times height, which the height of that triangle was the slant height, so that's why we have it there. But since I want to incorporate all the triangles around, we multiply it by the perimeter, because then that would get me all of the bases of all of the triangles. So capital B plus 1/2 capital P L. So we're still going to organize our thoughts. We're still going to know what big B is, just like we did with our prisms. We still need to know what big P is. But unlike a prism, the only thing I care about to find surface area is the slant height. Okay? Not the normal height. But we might need to know the normal height to find the slant height using the Pythagorean theorem. All right, so let's go ahead and look at this one, see if we got everything we need. Find the surface area of the pyramid. Well, you could, but notice which height is that 10 pointing to? It's already pointing to the slant height, so I already have it. So I don't need to find it. So this one's pretty easy, right? So the area of my base, if they just give you one dimension, assume it's a square. So the area of that square would be what? 8 times 8, so 64. The perimeter would be 8 plus 8 plus 8 plus 8, or 8 times 4, which is 32. My slant height is already given as 10. So we plug it into your formula. So surface area is equal to one of our b's, because we only have one base, plus 1/2 my perimeter, which is 32, times 10. So let's do this math. Half of 32 is 16 times 10. It's 160 plus 64. So 4 plus 0 is 4. 6 plus 6 is 12. Carry the 1. So 224. We're still in surface area. So we need to do units squared, so centimeters squared. Okay? So pyramids. If you have the formula in front of you, it shouldn't be too complicated. All right, so now let's do one where we have to find the slant height. So again, I've got another square base. So what's my capital B going to be? 40 times 40 is 600. Good. My perimeter would be 40 times 4. So 160. Okay, now we need to find the slant height. Now notice my arrow is pointing to the height of the prism, not the slant height. So this is where we do need to use the Pythagorean theorem. So I'm going to kind of make a right triangle right there, where my one leg is 21. What's the other leg? 20. Good. And that's where the most common mistake is going to occur. You guys are going to make that leg 40, and it's not. It's always half the base edge. Okay, so 21 squared plus 20 squared is equal to x squared. I cheat and use my calculator. 21 squared plus 20 squared is 841. Square rooting that, oops, gets me 29 for my slant height. So my slant height is 29. So once we have all three of those things, just plug it in. Surface area is equal to one of our B's, so 1600 plus 1/2 my perimeter, which is 160, times your slant height. So 1600 plus 0.5 times 160 times 29 gets me 3,920 feet squared. Okay? Pyramids. Not too crazy? All right, take a moment, write that formula on your index card. And what other notes you want to put on there as a refresher?
What did you say about, like when you have like the right triangle inside of
So this leg will always be half your base edge. And you only need to use the Pythagorean theorem to find a slant height when you don't know it. So if you're given the height of the prism, then you need to use the Pythagorean theorem to find the slant height. If you're given the slant height in that first example, then we're okay. All right, so the beauty of a pyramid and a cone is that they're kind of the same thing, but instead, my base shape is always going to be a circle. So what's our area formula for a circle? Pi times radius squared. And think about yesterday, another name for the perimeter of a circle is the circumference. So what's your circumference formula? 2 pi r times your slant height. Well, what happens when you do 1/2 times 2? It just goes away to 1, right? So that leads me to my formula for a right cylinder. So again, we only have one base, and for a cylinder, my base is always going to be a circle. So surface area is equal to pi r squared plus, and 1/2 times the circumference is just pi r times your slant height. Okay. So again, L stands for slant height. I couldn't really find a cursive R on my computer, so that's why it's italicized, huh? Yep. Okay, so when we're finding the surface area of a right cylinder, it still may be necessary to use the Pythagorean theorem because we're still going to have that right triangle. So if we look here at this diagram, your slant height is still the height on the side. Your height of the cylinder itself is still that perpendicular distance from the top, your vertex, down to the center of your circle. So you still do have a right triangle with your height and your slant height. And notice that your leg would be the radius. Okay? So the Pythagorean theorem still may apply. If you're given the height, but you need to solve for your slant height, you would just do an a squared plus b squared equals c squared. All right, does everybody see that? So you still have the same right triangle. All right, so let's jump down to the example. Find the surface area of the cone. So the only thing we really need to know for that is our radius and our slant height. I'm given a radius of 6. Am I given the slant height? Yes or no? Nope, I'm given the normal height. So to find the slant height, we have to do a Pythagorean theorem. So 6 squared plus 8 squared equals x squared. 36 plus 64 is 100. So what's my slant height going to be? 10, good. So 10 is equal to x, so my slant height is 10. So now we have all the variables that we need for our formula. So surface area is equal to pi times my radius, which is 6 squared, plus pi times my radius of 6 times my slant height of 10. And here I definitely need my calculator because I can't do this in my head with pi. So pi times 6 squared plus pi times 6 times 10. I'm getting 301.6 meters squared. So, on your index card, make sure you have Euler's theorem. Make sure you have the 4 formulas for surface area. 1 for prism, 1 for cylinder, 1 for pyramid, 1 for cone. Okay? I would maybe have the Pythagorean theorem on there if you don't have that memorized. For a prism, you might need to find the area of a triangle or the area of a rectangle. So if you don't know those formulas, put those down. Because this whole entire chapter is about surface area and volume, I will be taking off half points if you forget units squared. So maybe somewhere on there, but don't forget units squared. So you don't lose half points each time, because that can dock you down some points. So if it doesn't say meters, if it doesn't say centimeters, if it doesn't have some type of measurement, then just put a generic U for unit and square it. Okay? All right, so this is what you need to do